Okay. Oh, we are live. Yes. I guess. Can you see something? Can you hear something? I don't know. It looks good. It looks good. Okay. Oh, it sounds good as well. So okay, cool. I didn't meant to show this screen with this deprecated IP address. Of course, I want to advertise the domain I fully control and intend to keep paying for, that I will always redirect to the current host. Why do I even mention it that extensively this time is because, wait, I really need my OBS on the side here. And the reason that I mention it that extensively is because the server is currently running on a different IP since a few days. I did a world backup and we had a big ass downtime of, I guess, 2 days or something like that, and one night, so it was crazy. Yeah, so I actually don't want to show that. So the thing is, I'm going to install a third screen again, and I was thinking about doing it before the stream, but then I was like, why? You know? And that's why I'm doing it right now. So, okay, do I have space here? Oh, where did I put my fucking screen? Oh, that's so inconvenient that I put it there. Yeah, whatever. Okay. Please don't die. Shit. Almost killed myself on stream. Oh, by the way, I killed myself off stream in game. That's too bad, isn't it? Something's really hot here. I was messing around with my trap, and last stream I didn't finish it, so I decided to place the TNT everywhere, and then I tested it, and of course it blew up. So that's the, where's my, here. Yes, and the reason I'm streaming now is because I found this correlation of when I'm streaming that the server has more players. I don't understand how that's the case, but it seems to be. So, and I currently need more players for some performance testing since I moved the server again to my local machine. I increased, oh yeah, because before I did the backup, the server was always crashing when there were, please don't die. Oh yeah, Minecraft in full screen is probably not the wisest of ideas. Ah, okay, well that was an easy fix. It's still configured correctly. Okay, so I can show here the stream and OBS. Like, I can't even remember how I did it the last time. I could open the live chat as well, now that I have 3 screens. That might actually be feasible. How can I resize this? Why is the live chat so big? Okay. So, yeah, we can join. Yeah, so that's why we currently run on different hardware, and I want to see how different it performs just for testing purposes. And yeah, this stream should probably be a duping stream, so I even need a second device. Because yeah, I just blew up all my stuff. That is actually bad. I wonder where my second account is. Let me quickly log in there. Well, quickly. Oh my gosh. Where do I put my microphone? Oh, I have to make sure. No, that's fine. Okay. Because one of my laptop's partition has messed up graphics drivers, but that's I don't need graphic drivers if I'm not recording, so it's fine if I boot into my favorite partition. Yeah, I don't know, like starting the stream without information or action. I would say it's generally a bad idea for like viewers turning off if it's slow. So it's starting so boring, especially if it's an upload afterwards. But I don't know, it doesn't seem to perform better when I try hard to make these streams efficient, so to say. Efficient might be the wrong word, but you know what I mean. Oh, that's too old, isn't it? What version are we on? 1 second. Seems like I got bamboozled. Okay, I think we are at 1.16.4. Is that a breaking version? Wait. I don't know, like, whatever. Let's just launch this shit. No. Wrong account. Oh my gosh. You're currently not logged in. Okay. So how interesting is the stream right now? What do you guys say? Oh, I can have actually 0 viewers. That means all the time I had 1 viewer, it was not myself, but an actual viewer. Oh, and I was always talking like nobody's watching anyways. Poor that 1 viewer that like got offended probably. Okay, that's a breaking version, so I have to update my game. How do I even update my game? Edit instance, version, change version. Oh, what? No, that's wrong. Here, change version to. So isn't that the patch? You have like major, minor patch, and patches shouldn't be protocol breaking. Isn't that like a common scheme? So how is 1.16 not compatible with 1.16? Crazy ass bitches. Okay, so where am I? Oh, I am at my Duke base. It's kind of fucked up. No, it's wonderful. I will go there. That's such a nice place to do the things. We also get some charging for my duping device. I mean, it's still in the 200 by 200 radius, isn't it? So, oh no, it's in the 1000 by 1000 radius, I think. So it might be a bit close, but we'll see. Okay, then let's head there. Where am I even? Where am I? Anything that looks familiar? Well, that's definitely the way I'm coming from, as you can tell. How do I find shit? I mean, I knew coordinates at some point. Well, I could also like check coordinates. I'm at minus 300, 800. Please don't rate my dupe stash. Wait, that's wrong direction. Like this. What is making these sounds? Some of my devices. Ah, it's my dupe machine. That's fine. Okay. So okay, yeah, I think from here on I know where it is. Don't I? Yeah, that looks familiar. Oh, or was that the... Ah, no, it's the current one. The old one was like right next to it and then it got found and I moved a few blocks. Something like that. Okay, well... At least the chests are still here. So... Yay. 15, 7, 6. That's all not very quality shulkers. Nothing I want in my inventory right now. Okay. So I need another mouse. Which one did I use for duping? Which one is this? Should I use the same twice? Okay. Can I plug it in here as well? Awesome. Then I can wire this up like that. And can I move? Yes, I can. Okay, cool. Cool. So, for everybody who is interested in how to dupe in 1.16.14, what? .4? Still don't know the current version. It's not displayed anywhere, I know. Then, yeah, watch closely, since I'm about to do some magic. Oh, that's why it looks so fucked up, because the floor was full of shulkers, wasn't it? Okay, so what do you want to do? Those are nice. Kit starter. So I'm missing the kit starter. Oh, I think I've moved more shulkers out there, then the server crashed, and that's why my e-chest is so full, so I only missed these two. Okay, that's nice. That's nice. Then let's start with this baby. Then we go to the second machine. We hop onto the llama. Then I go over the disconnect button on my second account, right? So I'm mounted on the llama and I'm about to disconnect. Now I align both of my mice next to each other. So I have the right click and the left click like in the middle, so like so I can press left click on the one account and right click on the one account with the least amount of possible distance. I don't know if that makes any sense, but now I can smash both at the same time, and I make the move that you use to like pick out people's eyes. You could also call it like the peace sign or something like that, and then I smash it onto the two mice. Pam! And as you can see, since with this account I picked up the shulker while the other one was disconnecting, and if I was lucky now, then the timing was on my side as it was. Cool, so now we have it still in here and in my inventory. So that's nice, we can refill that one. We still have this one in here, right? Cool. And now we do it again. And since it's now timing based, it's a bit lucky, even with my, I would say, pretty solid setup, where I like can click both of them with one move. I use like two devices, two mice, and so on. But as you can see, it doesn't work all the time, and that's bad. I have no idea how this works with one device. I don't think you can like. Maybe you can emulate 2 mouse clicks on one machine or something like that. It might be even easier if you have the correct hacks installed that manage 2 clients at the same time. But yeah. It was easier at some point for sure. Okay, and that's how today's session is probably going to go. I will quickly search for a video that wow, that's a little bit small, isn't it? That I'm going to watch, because this is going to be boring. Smart pointers in. Do we want to watch another Crust of Rust? These are so. I want something more easy on the ears. What about ownership closures and threats? No. Let's check out Coding Tech, the rip-off Creative Commons tech channel. No, nothing interesting here. Do I have something in my watch later? Internet censorship in the Catalan referendum. Bootkits for Apple macOS. Nothing that really piques my interest. That is too bad. There was this one guy who gave me permission to watch his videos. I don't know if I wanted to watch his videos. Here, that one. What was he talking about? Opening old wounds, why Uber engineering switched from Postgres to MySQL. So that guy gave me permission, or gave another of my accounts permission. Is there a hole in the roof? What? Oh, that's bad. Gotta fix that. Don't wanna get blown up here. Also, is there enough light? I can't tell. I'm scared of creepers and shit. Yeah, that's probably enough light. I mean, oh my gosh, why is it so? Okay. What, man? It's so griefed. Okay, now I should be safe. Okay, cool. Let's see. And what does he talk about?
Row. Yep.
Yeah, let's watch this one. Opening old wounds. I can't pronounce it. I'm sorry. Why Uber engineering switched from Postgres to MySQL. A video from 2020. It has 6,000 views from the Hussein Nasser channel, and I pronounced that wrong as always. Cool. So let me quickly copy that. Go over here. Then we set that as the channel we watch talks from, and then we set the title to the title. Opening words. Oh, not words. Oh my gosh, I should stop talking. Cool. And then we set the URL. To that. If this is shit now, I'm gonna rage. Pop Bob is my daddy. Oh my gosh, we have a 2B2T player here. Awesome. Okay, so now I should have fixed the stream title. I wish I could resize it. The chat is not so big ass. I can do it like that, so I don't see chat at all. That's how I usually do it. Oh, I can probably also zoom. Yeah, that's juicy. Okay. Okay, cool. Wonderful. So let's start from the beginning, maybe.
What is going on, guys? My name is Hussein, and
Hussein, well,
this is an old but gold article.
1 second, let me get something to drink. Okay. Let's go.
Uber engineering switched from Postgres to MySQL. And this article was published on July 26, 2016. And this article explains why Uber moved from Postgres to MySQL. Back in the days, I remember that this article got a lot of backlash from the Postgres community and actually the whole database community, to be honest, because of how the language used in this article severely criticized Postgres as if it's a bad database, right? They don't even mention that thing, that they say, hey, by the way, guys, this is just didn't work for us. It doesn't mean it won't work for you. So that was the main reason this article was heavily criticized. I'm going to reference below this article and the Hacker News thread that explains that. They're just going to have a lot of discussions. Some discussions go into the deep, some discussions kind of point the flaws of this article. But what I want to do in this video/podcast is going to go through this article and through the main pain point that Uber had, and then discuss them, give you my personal opinion, whether I think Uber moving from Postgres,
Nice.
did they have to move from Postgres to MySQL or not? all of that stuff. How about we jump into it, guys? So guys, first they explain that their architecture right here, they have a monolithic backend application written in Python that used Postgres for data persistence, and they're moving that, again, this is 2016, things can change, but they're moving to a microservices architecture, and surprisingly, to a new system using schemaless. It's a novel database sharding layer built on top of MySQL. So we're gonna talk about that a little bit. That is a little bit of flag. You might say, Hussein, why schemaless and MySQL? That doesn't make any sense, right? Exactly. That's a lot of people confused. Oh, okay. Why would you pick MySQL for schemaless? Just go with
It's still broken. I hate my life.
CockroachDB. I don't think CockroachDB was born back then. But Fauna, Mongo, right? Anything. But yeah, again, they have their own reasons, and that's another article. But what I want to focus in here is the architecture of Postgres, as they claim. So here's the for the people listening, we're reading now the architecture of Postgres, and I'm gonna read the article, the 5 most pain points that led Uber to move from.
Why can't I
Postgres
connect to the
MySQL.
server? What heck, man?
So this is the article now. We encountered many Postgres limitations.
Are you
First,
kidding me?
Inefficient architecture for writes. The second one, inefficient data replication. The third one, issue with table corruption. Issues with table corruption. Issues, not issue. And there's the fourth one, poor replica MVCC, multi-version concurrency control support.
What?
And the fifth one is the final one, difficulty upgrading to new releases. I kind of agree with some of them because I use Postgres and I know how painful it is to upgrade Postgres. So I kind of related to that. I understand that this is a little bit easier process right now, but nevertheless, how about I don't agree with all the points, by the way, but I'm just reading out to you. I agree with some of them is just, to me, preposterous. So how about we jump into it? So they look through the limitation and they decide to move to MySQL because it solves most of these problems. So how about we jump into one point after another. So the first point here, that's called the on-disk format. They are describing in this article, in this section, the on-disk format of Postgres that implements a multi-version concurrency control. And we talked about it many times in this channel, how the actual indexes are stored, how secondary indexes are stored in Postgres. How do they implement the multi-version concurrency control using the transaction ID, the TID, right? And then max ID and min ID, and how a row becomes visible in my transaction. Once I go out of scope of the transaction, I need to do a vacuum to clean up those rows that no longer seen by any other transaction. So that's all comes down to the isolation and all that stuff that we talked about many times on this channel. So check out the ACID video here to learn about isolation, ACID atomicity. I'm not gonna explain it right here. So that's why I explained here. So what they are going through here is they have a table called users, and they're showing you how Postgres works. So for the people listening to the podcast, we're looking at a table with 4.
Oh, that's awesome. He has a
ID,
podcast.
first, last, and birth year. So first name, last year, name.
No,
birthday.
fuck.
And then there's an ID is a number, first name
Fuck.
is obviously string, last name.
Stop recording. How did it affect the stream? Shit. I started a videos.
Last year, yeah.
I started a recording when I wanted to. Oh my gosh. So what I wanted to say is it's awesome. He seems to have a podcast which comes in really handy for me while I play games, when he tries to make it accessible for people that just listen. I abuse YouTube in that regard anyways. I should be watching listening podcasts. but I still glance over here and then, but I'm not watching active enough. So this might be a pretty good, how do you say, is it compromise? It's a pretty good format that I can easily consume and get the most out of it, I think. So yeah, maybe I think that guy actually changes his license in the future to Creative Commons. If I can trust his comment response, then yeah, that might be another channel we can binge watch in here. Let's see about that. But for now, I'm not disappointed. I mean, he didn't mess something up. I'm not saying that's the best shit I've ever watched, and he's just talking about this article. But that's really nice because I find it somewhat interesting, and I would probably never read that article, especially not on stream. So that's that. Anyways, let's continue and not start a recording. Ah, fuck.
There's a string, character, and then birth year. And they show you how this is on disk. And there's a CTID, which is a transaction ID that is stored. That's basically the tuple reference on the disk. And this is very, very important. So these tuples are A, B, C, D, E, F, G, and so on. So the primary key, they have an index on the primary key, which is the ID. They have a secondary index on the first, last, and birth year. So they have indexes on all of them. And again, this is just an example. They didn't show us their architecture for security reasons, probably. So they don't show us their schema, nothing like that. But from this example, that tells me that they have a lot of indexes. So pay attention to that. So Postgres, their primary key and secondary key always point to the tuple ID, which is the physical representation on disk, right? And here's how Postgres works. So if you now go ahead and update a row, any row in this table, what we do is we essentially insert a duplicate row with a new tuple ID, this TID, right? And now that we have a new ID, we need to point the indexes, the secondary indexes, and pretty much everything that uses this tuple ID to the new representation, right? And that takes finite amount of time, finite amount of writes, finite amount of work for Postgres to do, right? Because everything points directly to the disk. Just like my ISAM and MySQL, that's exactly the same architecture where everything points directly to disk. And you might say, what's bad about this? There's good and bad. The bad thing is what they are explaining here is this: hey, the moment we touch any row, I have to update all the indexes, including the primary key, because now all these indexes have a new those entries have a new ID that I need to pick up, tuple ID. So I have to update that, and that obviously takes a ripple effect. They call it write amplification in the coming slides, right? And this logical write, so I updated a single field in a single row, yet it results on 5, 6, 7 writes, physical writes to disk, because you're updating this secondary index, this secondary index, this secondary. If you have a lot of indexes, so you can get slower and slower and slower, right? So bear with me here, right? So this is, I'm just explaining their point now. So they go through all of that, so exactly what I said, and that, as a result, slows things down, because first of all, writes are not slow per se, because you do a flush, right? You have a lot of writes to do, and then you do all of them at once. But the side effect of the writes, we're gonna explain it in a minute. It's like one single thing translates to a lot of physical writes. I have to update this index, this index, this index, this index. the write ahead log, which is something we're gonna explain in this article a lot, gets large when you want to apply these changes. So that's the first thing. On disk, they go through the on disk representation of Postgres.
So
Then they explain.
I'm full
the second
already.
point
That's
is
surprising somehow.
replication. And replication here, guys, as I discussed, the write ahead log is basically if I do an insert, if I do an update, this statement is translated into physical changes. Hey, go to this block and change this location and replace this value with this value, right? Or go to this index and change this value to this value. Go to this index on this position, change this. These changes are written in the write ahead log as actual disk changes. Okay, so that's the very important thing to know. Now this is the write ahead log. We have this, and also the write ahead log has its own structure, right? It's somewhere else, and it's being maintained. So that's also the write ahead log also has with physical representation on disk when you translate it into an SSD, right? So there is a lot going on. So now, when you come to replication, which we talked about right here, guys, and also discussed in my course, Introduction to Database Engineering, the idea of having a primary database, accept the writes, and standby replication for reads, that can take reads, you need to push these changes. And the way you push them is, you push the write ahead log, which is a very consistent thing, down these standby databases.
Oh,
so they
what?
can get up to date, right? So
Did I just dupe a deprecated kit? Oh no, it still has fucking diamond tools in there. Okay, that's bad. Okay, let me quickly get rid of some trash. Okay. I need some kits. Kits are always good. Ah, that was too early. Way too early. No, it wasn't? Well, then I don't understand how this game works. This was perfect. Okay, it was. Well, I don't know. Okay, so efficiency, we want the non-silk touch one and put it in here. Herausragend. Oh my gosh, a German joke. Okay, is there anything else we can improve? I guess otherwise it's a top-notch kit. Maybe more TNT, less totems. I usually don't die that often. Let's be honest. I'm pro. So I usually need more TNT or slime. What do we put in here? Slime or TNT or wood or like eaches? Nah. I don't know what to put in here, to be honest. Okay, let's put in some. I actually need a lot of slime. I would love to trade. Oh my gosh, I was like thinking about how can I use the slot efficiently. I want iron and some other block on there because I don't need that much of an iron. So I was thinking about using a C++ union. I'm such a nerd. I like it literally blinked in my brain for 1 second. Oh, awesome! I want 2 different types in one slot of memory. Let's use a union. Oh my! This is I don't know why I'm telling. This is somehow embarrassing. Whatever. Okay, and brain dead. But it would be awesome to have like half of the slot used as iron and half of the slot used as something else. But do you know if is there a way? Maybe can I transport the iron less efficient and ship something else with something that you can craft back to iron, something like these anvils. Wait, can you craft anvils back what am I even doing here? But no. you can't. It would be funny if I had anvils in my chest. Anyways, so that doesn't work. Is there anything else other than iron blocks that can be reverted to iron? Anything that drops iron? Nah, I don't think so. So, too bad. I could, instead of blocks, use the ingots, so I don't have to craft. More TNT or more slime? And also the same with the, I don't need so many blocks of redstone. Should I throw away more totems? Or gapples? Or... What? Such a hard decision. Okay, that's a better kit now. For sure. Is it really good though? I don't know. I see space for optimization, but I don't see what exactly. Yeah, so yeah, let's go. That's the good one, right? Put the bad one in here, and let's do a few more of those.
Sounds simple. And what they explain here in the replication format, and this is where kind of their point about the limitation of Postgres is. You guys have this. First of all, you have this write deadlock, which is quite large. Why? Because a single update statement translating to multiple writes, and these writes are made its way to the write ahead log. So the write ahead log doesn't have update this table. It's not like statement based replication. Despite Postgres support statement based replication through a third party, I believe, the MySQL have both supported both data statement based replication and also write based replication. There is again pros and cons for both. So now when we try to apply that, came back, the dog was barking. All right, so the master database pushes the wall changes down to the standby databases so they can get updated. But they might say, Hussein, what if the standby is actually executing a query. Do we just stop this query, right? Let's say I'm executing a query in the standby to read something that happened to be deleted in the master, and it's being written directly. So I stop do I stop the query? Do I wait? All these questions are gonna get answered in a minute, and as a result, it will shape their decision to move to MySQL. I'm gonna explain it to you. So now we talked about the on-desk representation. We talked about replication, and now we're gonna talk about the consequences of Postgres design. That's the third point here, where the problems of Postgres. So let's enjoy this. Really. The first problem is write amplification, and write amplification is apparently something is in SSD, where a single write that you think it's logical translate to many physical writes, especially in SSD. SSD does its own thing. So when you update versus insert, SSD does a little bit different thing. SSDs love to insert new things. You have to logically just insert new things and create new pages. SSD does not do well with updates, because the goal of SSD is to have a page and flush it. In order to update an existing page, you have to invalidate that existing page. You take it and then you copy it, change it, and then write it. So there's a little bit more work when it comes to an update versus an insert, which is faster. So that's all the reason why Google invented the Level DB database, and then why Facebook invented RocksDB on top of that, I think, that to take advantage of SSDs, and they built a completely different structure called the log structured merge tree, where it's optimized for inserts instead of updates. Right? So everything is an insert almost in the log structure merge tree. So that's the idea of write amplification in SSD. Now take that and amplify it at the Postgres level. A client, I'm doing a single update statement to my table. And if I have like 700 indexes, I just made 700 updates, physical updates, as a result of my single.
Okay, do I need another starter kit? Is this one actually a good one?
This 700 updates also at the SSD level translate to many physical amplified SSD updates, because you go in writes and pages, and SSD, poor thing, they have a limited shelf life. So if you have a limited shelf life in SSD, you can only write so much. I think there's a number that varies between a disk and another, but in general, it's essentially, I think, 12,000 times or something like that. That's most of them. So yeah, so they explain this here. I just summarized it to you. Write amplification is a problem for them. So their SSD is getting their lifespan of SSD is getting lower and lower because of the write amplification, because those guys have hundreds and hundreds of indexes. Why would you have this much indexes? Beats me. Do you really query on all of them? Do you really query on first name, right, or last name? That's why adding indexes is great. Adding too much indexes is just a bad idea. So that's the write amplification problem. The second problem they want to discuss here is the replication problem. Guys, take the same thing that we did. We did a single update that translated to lots of update to all the indexes, because all of the indexes point to the row directly, so, and the row ID changes, so we have to make them aware of this row changes. So all of these indexes point to the row directly. So these changes are just amplified. Now,
what is this kit
these
then?
changes translate to what? To a wall.
More sponges, huh?
Like add log. Hey, update this physical index, and this index, and this second, and this. And by the way, there is a row here, change this value to this, and this. It's all physical write to the disk. What they complain about in their applications is this wall translate to a large, big sized bandwidth when it comes to their master worker or standby replication. And those are interstate. They have their replicas across states, across different countries. So they had to buy expensive bandwidth to kind of transmit their wall changes from this replica to this replica. And I believe they have also grandchild replication, so take that into consideration. So the wall changes, as they grow large, the bandwidth becomes expensive because they are very large. And they're not making small updates, they're making large updates, which means they're even larger. So that's the limitation problem here. In case I'm gonna read this section for you guys, so you can learn more about it. In case where Postgres replication happens purely within a single data center, the replication bandwidth may not be a problem. Modern network equipment and switches can handle a large amount of bandwidth, and many host providers offer free or cheap intra-data center bandwidth. Right. If you are internally, I can transfer 1 gig of wall sizes easily. However, when replication must happen between data centers, issues can quickly escalate. For instance, Uber originally used a physical servers in co-location space. I don't know what the heck is a co-location. Co-location space on the West Coast. For disaster recovery purposes, we added servers in second East Coast co-location space. In this design, we had a master Postgres instance plus replicas in Western data center and set of replication in East one. So that kind of the constraint you can see from East to West just did not scale for them, right? Because of that. See one.
Is that even something I want to carry around with me? These are much more efficient for travel.
You see the pattern, guys? Writes are big because they have a lot of indexes. That's where you should start. Why do you have this much indexes? You might say, hey, Hussein, I cannot live. I have to have 350 indexes on all my fields because I query against them. Well, in this case, it's like, okay, maybe that's not a choice for you then. But try to avoid that in the first place. That's what I didn't see, and that's why people are pissed. It's like, wow, did you really didn't you explain why do you guys have a lot of indexes? Can you explain why do you need? I bet if you go into the actual architecture, most things don't need this much indexes. As a result, you will not translate to a huge write amplification consequences. You will not have that because you will not have a lot of indexes to update, right? But, well, we're not an Uber, so we don't know their architecture, but that might be a valid use case. So let's go to the data corruption. This is the most dumb section in this whole article. I'll save you some time. What they say here is, hey, during the replication, Postgres 9.2 had a bug in it, and our table was corrupted as a result. Seriously, Uber? What software doesn't have bugs? You're adding a bug as a result to move from Postgres to MySQL, like MySQL is perfect? That's just odd. That's just, to me, I'm sorry, that's just odd. So they said during the replication process, the replicas were not in sync for some reason, and as a result, when you query for a unique value, let's say select start from users where ID equal 4, you should get 1, right? They were getting 2. They were getting the old retired row for some reason, right? And that causes their application to fall down and then fall apart. So they had to add defensive programming and then to catch for this stuff, but it's a bug. Postgres immediately, if they notified Postgres team, they would immediately have fixed it and fixed that bug immediately. But that's a good bug, but I don't see bugs as a reason to move from as
Oh,
a
come on.
showstopper, in my opinion. So they talk about that, and they talk about here, one section is the B3 rebalancing, which is, by the way, B3 rebalancing adds to the write amplification. They don't mention that, but it's just implied, because a lot of people know that. When you insert to a row and you have a lot of indexes, you keep updating those indexes naturally if your value touches that index, right? However, as a result of inserting, the B-tree structure might need to rebalance itself. And when it needs to rebalance itself, it actually doesn't physical update to the tree. And updates are updates, not inserts, right? So updates translate to what? To actual SSD write amplifications, because SSD do not like updates. So that's another thing that can amplify the writes. I'm talking if you go to the millions of rows, right, obviously. Right, let's move to the next one. Replica MVCC. All right, replica MVCC, or replica multi-version concurrency control. It says, Postgres does not have true replica MVCC. Well, why? Because the fact that replicas apply wall updates directly, right? Because if you think about it, Postgres by default, by default, takes the on-disk representation of the wall changes, and that's what gets transmitted. So it's often higher bandwidth, but if you think about it, it's faster, right? The alternative is just do statement-based replication, right? Where instead of sending the results of the execution of the queries, send the queries themselves. Like, hey, I just did an insert, I just did an update, I just did an. So the actual string of the statements, the SQL statement, just send them to the replica. This will be way slower, right? Because yeah, the bandwidth of transmitting these wall changes as form of statement is smaller than the actual physical changes that happen. However, applying them to the replica, now you have to actually, inserts are not, straightforward inserts might be okay, but what if you do an update, for example? An update could scan, could touch the index, actually does work. So you did double the work technically, right? Because you did the work to execute the statement on the master. You now are doing the same work exactly, and that statement is expensive. You gotta take the same cost on the server and the destination. So there is a pros and cons for using both. But they are complaining here that Postgres wall update is just doesn't give them MVCC support. So let's clear that. So let's say if I am in a replica standby and I'm executing a query, and one of my wall changes affects that query that is being executed on the standby. So again, I have a master. I deleted. Let's say I deleted a table. That's just a little bit harsh, but let's say I deleted a few rows, right? And now on the standby,
Diamonds.
I'm actually querying those rows that is being deleted on the master. I am on a different replica. So now I am pushing the master, pushing the wall changes to the standby, while that query that is querying those deleted rows is being executed. What should Postgres do? You tell me as the viewer, listener, what do you think should happen here? Should the Postgres immediately cancel the query, right, and write the changes, or should the wall changes be paused until the query finishes? If you think about it, there are no other choices, right? You have to pause it. Obviously, you're not pausing all wall changes. You're only pausing changes that affect running transaction, and that's another thing to worry about. How the heck do I know that the query that are being executed actually affects my world changes? Building databases is not easy, guys. Look at all this complexity. So they're complaining here that you guys don't have VCC support because what you're doing is, what Postgres does effectively is essentially having a timeout. It says, hey, we're gonna block the wall changes for a given timeout, and they give you this timeout configurable. If the query didn't finish in this amount of time, we're gonna cancel those changes. We're gonna cancel the query that is actually querying, it's reading, and while we're applying, we're gonna force applying the changes. Why? Because Postgres design favor eventual consistency over, let's say, just reading queries, right, in this case, right? So I rather be eventually consistent. Remember, this is eventually consistent as well. So stop saying that NoSQL is the only database has eventual consistency. Every database has it, as long as between replicas, right? Relational doesn't. In the same instance, yeah, it's completely consistent, but across replicas, there is always this idea of eventual consistency. So what Postgres does is actually kills the transaction, and they did not like that. So guys, let's read this a little bit. I kind of don't agree with this statement, right? The design means that replicas can routinely lag seconds behind master, obviously, and therefore it is easy to write code that results in kill transaction. What does that mean? This problem might not be apparent to the application developer writing code that obscure where the transaction start and end. For instance, say a developer has some code that has to email a receipt to a user, depending on how it's written. The code may implicitly have a database transaction that holds open until the email finishes the sending. That's just a bad idea, right? You don't hold a transaction open and you do stuff has nothing to do with the transaction itself. Try to avoid that as much as possible. So that's just a best practice. While it's always bad form to let your code hold open database transaction while performing unrelated working I/O. Okay, thankfully they mentioned that. The reality is that most engineers are not database expert and may not always understand this problem. I have to disagree with this one. Again, guys, if you know me from this channel or the podcast, you know that work as an engineer, you have to take pride of your work and the thing that you interface with. I believe that you have to understand what you're communicating with. So yeah, engineers are not database expert, but this does not qualify as a database expert. This is just basic transaction management, in my opinion, right? And I believe engineers have to understand this, right? And engineers have to understand. If you might be not as radical as me. I don't like to work with anything that I don't understand. If it's black box, I don't like to work with it. Before I pick a tool, I have to understand fully how it actually works, fully from 0 to 100%. If I'm working on it, if I'm connecting with it, if I'm interfacing with it, it's okay if I understand 80-70% of the tool, right? But again, I'm not going to understand every single thing in that case, right? But that's just me. You might have a different opinion. Postgres upgrades. So I kind of agree with them.
That's actually.
I try to upgrade people.
This approach is actually nice because if you run into issues, well, first of all, you run into less issues because all the obvious bugs and pitfalls, you know them if you know the tool you're working with. And if you run into the issues, you fastly know how to debug them because you understand what's going on. On the other hand, this requires a shit ton of time when working with something, or before working with something new, you have to investigate all of the time to make sure that you can start working with it, and that might delay projects so long that you even decide against using this tool at all and stay with the stuff you know, because you have no time or it doesn't seem worth it to invest so much research into a new tool that you don't even know yet because you didn't research it yet, and you didn't use it yet because you don't use stuff you don't know. So that can lead to this thing that you don't try out new stuff, and you're really good with the stuff you know, and at some point you lag behind. And that actually can work pretty well if you have a set of tools that does not change a lot and do not get replaced, then you work fine with that. And I would also say that I would also like aim at that I also just feel uncomfortable if I work with something that I don't understand, and so I also try to figure out stuff before I actually work with it and understand it. But I'm actually trying to fight this habit of mine to be more open for new technologies. Since what I noticed is that I know my tools, that I know how they work, and then I don't see any reason to spend much time looking into stuff. So I just don't use them. So what I'm trying to do nowadays is I try to just use them as I go. If I find bugs, I research those bugs, and then I learn about the problems when they arise. That is especially fine if it doesn't matter if the project blows up. I know if you run into serious issues and you're in a production environment, that's fucked up. But yeah, I guess this way can also be used to learn about the tools and then use them in projects that matter, and then you already know about them a lot more. I think, yeah, you have to balance that. It's maybe a bit harsh to say I don't touch anything before I investigated it fully, because that might block you from getting things done with the right tool because you didn't fully understand it. But yeah, I totally feel him. I also have this some sort of an anxiety or something like that, that if I use something that I don't fully understand and I'm like jumping from example to example, and there's this one thing like bugging me that I don't understand why this is like this and what is it doing in the background, that gives you just this like feeling that you are not in control, and it just works because your example code you copied from somewhere works. But if you want to change something, or if something goes wrong, you're fucked, and that's just intimidating to me. But yeah, whatever. I think, well, in detail, he is probably not that strict, and it's also kind of subjective on how you define fully knowing a tool and how long it takes for you to do that, and stuff like that. Because if you go like fully, then, well, that's simply not feasible time-wise. I mean, but he's probably not going that drastic, and so his approach is probably just fine. He just, if you take him like, how do you say, I don't want to say seriously, but like, how's it called? Like, if you take the words as he said them, that he always to 100% wants to understand any tool he works with, and he claims to be really strict about it, then that is simply not feasible. Like, I don't know what he defines as tool, but if you apply that mindset on the whole like ecosystem of software, and he probably is not even able to turn on his PC without bisecting or like reverse engineering his bootloader, because that's running his machine and that's some crucial tool he interferes with, isn't it? And then like read all the code of his web browser and whatnot, and read the documentation of the shell he's using and so on, right? And I think sometimes that is overkill. It's of course a nice habit, but it blocks you from getting things done sometimes, this mentality of understanding things. Sometimes it just works if you do it. But I'm sure he's balancing that off, but he's saying it a bit, how do you say it? He's probably exaggerating. How do you call it? Exaggerating it a bit. Or I might be misunderstanding him. And I would say I'm similar to him in that regard, but I'm not going too wide on it, and I just usually, it's more like a feeling-based thing than a fact-based thing when it comes to me. I just have to feel comfortable with the tool, that I think that I understand most of it, that there, or like at least the things that I have to use to get my projects running, that the things that I interfere with the tool, I have to understand what they are doing. If there's something else that I could do better, or something else that you could use, or if I extend it that I don't know about, then that's fine, because I'm not using that. At least if the stuff that I'm using makes any sense to me, that's fine. Right. I don't even have to know how a SQL update statement looks like syntactically. I don't even have to know that it exists if the only thing I do is inserting, for example, to be with a concrete example. And I think what he is referring to is that before I even use SQL or whatever, I have to understand what all these statements are and how they work in the background with these tuples and whatever. And yeah, I don't have to do that to feel comfortable. Maybe I'm different in that regard, if I understand it correctly. And I don't know why I'm talking so long about this, but I just felt like talking some random shit. As always, ignore what I say, and check out the original videos to give them credit and feedback, and not here, right? Because I'm not the person, like, if you're watching this on the YouTube channel, what are we, Lasergurkenland or something like that, then it is not me, Zillihoon, the maintainer of Lasergurkenland, talking about the databases. It's Hussein Nasser, whatever. And yeah, check out his video. It's linked in the description. Just wanted to make that sure, because I, from time to time, like essentially all of my comments, the 3 I got this year, say like, oh, why do you talk about this tech shit and you could do that? And like, they write comments under my videos that sound like they were talking to me, responding to the talks, and that's a bit weird. So maybe I say that. Whatever. Let's continue.
Many times, and always didn't find the right tutorial, or it was so complicated that I gave up. Right, and they kind of reiterate the same problem. So I had to agree with them 100% on this. Postgres application is really painful. Really painful. I've been there. I've been there from 9.3 to 9.4, 9.4 to 9.5. I then just gives up. I just rather recreate my databases from scratch after that. Obviously, I'm running a test database here, but yeah, I didn't run a production database that I had to upgrade it. But what I'm gonna do in this case is just, obviously, there is a way, but apparently this way sometimes works, sometimes it doesn't. So there is also the PG logical way of there's some tools that allow you to do upgrades, right? And guys, if you know any of that stuff, if you have ever upgraded Postgres database smoothly, let me know in the comment section below. I'd love to know how to do it. I tried twice, I believe, and I gave up and says, you know what, this is not straightforward. And I wasn't forced to do it, so I took the easy route of recreating my data. Okay, the architecture of MySQL. AnyDB. We talked about AnyDB, guys. Check out the video right here if you want to learn more about it. But AnyDB, So they go now through their own disk representation compared to Postgres. So AnyDB or just MySQL in general. MySQL or AnyDB in general, that's the right way of saying it. They have the primary key. And the primary
I
key
hate these
has
blocks.
a pointer to the row directly to the physical database on the scroll. All the indexes that you create points back to the primary key. And that's the powerful thing here for them. Because now, if I update anything on the row, only the primary key needs to be updated to know the new kind of row ID. And even that, right, it's a little bit different. But I don't have to touch my secondary indexes, right? That being said, guys, they didn't. That's not always true. If you're updating a field that has no index, then, right, you're gonna not touch only the primary key. But if you updated a field that has an index, you gotta touch both. So they didn't mention that, but yeah, right, because it's very defensive article, right? MySQL is perfect. Yeah, if you update the actual field that has a secondary index, you have to update the secondary index. You just updated a value. So you have to go to your index and change the tree so that includes this value, right? So yeah, you touch a lot of fields, right? And if you touch a lot of fields,
Oh my gosh,
then you have to
I'm
update all
trapped.
the indexes, right? It's just by design, it's less. If you have a lot of indexes, you have less changes in general, right? So as a result, this translates to obviously less wall changes because they don't have as much changes, logical to physical translation. And now they talk about the rollback mechanism here. That in MySQL they have this concept of rollback segments. So instead of inserting a row in the heap itself, when you update a row in a Postgres, you insert a row in the heap itself, in the table itself, right? MySQL and AnyDB does it differently. It's just they copy the row into some other place called the undo, the rollback segment, the undo logs, right? And they keep it all there. And then based on that, they point to that location in the rollback segments, right? So it's a little bit different architecture. So if you query now, if you want the latest is always there. So that's the beautiful thing. But based on your transaction ID, if you are coming from the past, you are querying in the past, you want older results, you have to do the jump to go back to get the older data. This jump doesn't exist in Postgres. So queries that are concurrent are faster on Postgres. They are technically slower in
Oh my gosh.
MySQL, because now you have to jump back and go through different places to do the query, right? And vice versa. So that they explain that, hey, secondary indexes point to the primary index and the primary index point to the disk. This is for people listening on the podcast. We're listening, we're watching, we're looking at a picture of secondary index pointing to the primary index, and then primary index is pointing to the disk. Right? That's just the next level. And then they claim that they say here that the replication section of MySQL supports multiple replication mode, statement-based and wall changes. And the moment if you implement any of these modes, if you implement statement-based replication, you have true MVC support, because now the statement, the wall changes that is coming to you from the master to the standby is just another write. They consider it another transaction trying to be executed. So it will have true MVCC support at that case. It will not be blocking, right? Because you can technically query and write at the same time. And now as a result, you can implement the same exact thing that you're doing, right? Because you have logical view of what is changing. As a result, the database is aware of the change. It can implement MVCC at the higher level, right? Even through replication. Postgres does support that. There is a third party that you can install and does exactly that. You can do that. It's just they just didn't mention that. Oh, again, guys, this is an old article, so things can change, obviously. Right. In MySQL, And they say that, oh, by the way, even the wall sizes are so small because we're changing very few things here. They go through all of that stuff. I'm not going to go through that, but that's essentially their advantage. They go through another advantage here of MySQL, saying that a buffer pool. The buffer pool is the caching mechanism in Postgres compared to buffer pool is the caching mechanism in MySQL compared to the caching mechanism in Postgres, which is basically the RSS memory, right? And they're explaining the difference here. They claim that Postgres uses a different operating system calls, like they're using 2 calls instead of 1. I don't know much about that, to be honest. I'm not an expert in operating systems, but a lot of people say that, yeah, you have to use a 1 call to seek and read at the same time instead of seeking and reading. I don't know, maybe Postgres actually changes. A lot of people here listening and watching this channel, some people actually are experts in this thing and might correct that part, but I'm not aware of that as a result, so I can't comment much on that part. There is then the AnarDB storage engine implements the least recently used buffer pool, and which you can apparently control. I'm surprised that you cannot control the cache size on Postgres. I need to read more about that a little bit. But that's another thing they say that is another advantage of MySQL. Then another thing says connection handling. In MySQL, there's a thread pair connection. Each TCP connection you open to MySQL is a thread on the server side. However, Postgres, it's an actual process. So technically now, they claim obviously in a thread is cheaper to spin off than a process. I read that this is no longer true because the process and thread is almost identical now. But could be back in the days, could be that was true. But now, if you think about it, to scale 10,000 connections, right now, if you think about it, opening a lot of TCP connections is just a bad idea. So that's why we have the idea of connection pooling, right? We build our application so they use a pool, reserve a pool, reserve a connection from the pool, execute the transaction, and then return it to the pool, right? And if you're doing a single atomic statement that executed, you can just execute on the pool directly. Say, hey, pick any pool, any instance in the pool, execute, and then return it immediately. Right, this reserve and release is also back to their queries. If they have a queries that span 3, 4, 5, 7 minutes, and again, nothing wrong with a query that transaction that stands long if you're actually doing all database works. Some transaction, I've seen transaction that takes 30 minutes just because it does a lot of work. It changes a lot of stuff, and these changes has to be atomic, right? Yeah, you can argue that you can break it. Even then, you have to break these transactions into small pieces, so that each piece can be executed in its own atomic manner, right? So you can minimize the transaction size. So this also results in, if you have a long-running transactions, then you have to really think about how do the reservation and connection pooling works, right? So the number of connection, right? Think about it so that if a client is not using a connection, then don't let them open a connection and just have it open. Use connection pooling, and they say they use I believe PG Bouncer, is that what they're using? Some service that actually does that connection pooling. But a lot of applications do it. Even if you don't, you can build your own layer on top. And I showed connection pooling on Postgres many times in this channel. Right, that's the idea, guys. And hopefully in the future, we're at the end of the article, obviously, guys, right? We're at the end of the article. But hopefully, when it comes to connection pooling, I really hope that Quick as a protocol, and Mask, I believe they're just working on a new protocol right now, it's called Mask, that will allow you to kind of stream open multiple streams on a given TCP connection or UDP connection in case of Quick. that represents your database connection. So that if MySQL or Postgres supported quick, and I don't see a reason why not, then the client can open a single, and remember the client is always a broad server or something like that, right? So you open a single connection and have up to 200, even more than that, streams concurrently in a single TCP connection. The only trick here is the database has to understand the idea of streams. So that's a lot of work, but I believe it's going to be really lucrative for a database to implement a protocol like that. Just like I don't really need TCP anymore, right? A single TCP is just a wasteful thing to have a single TCP connection for a given client, right? Or connection pooling. This has to go away, and we have to move to a model where we multiplex queries in a single TCP connection using this protocol, right? Whether you're using, even if they implemented their own, they don't have to use Quick. You just implement your own protocol that supports multiplexing, true multiplexing, so that every request, every session, every channel has its own logical representation in that TCP connection that you open. So this you don't have to open many connections, you just have to open one or few of them, and each one of them has basically some limit. Obviously that doesn't come with it for free, because now you just increase the CPU size at the back end and the front end, because now you have to assemble these channels and streams. That's the problem with HTTP2 and Quick. People start, Lucas Perdue and what's his name, Chris Wood, and people working on the Quick protocol. They're trying to solve this problem with the CPU usage, right? Because CPU usage, now you're just not working with just stream of content coming from TCP socket. No, you have to actually look at the data and then arrange the packets so they are in logical streams or channels, and then deliver it to the app. So the operating system or the application, wherever this thing lives, doing extra work. So again, I'm sorry about that segue, but I want to discuss that a little bit. I think that's just an idea that is just great. Conclusion, obviously, they say, hey, Postgres served us well in the early days of Uber, but we ran into significant problems scaling Postgres with our growth. Today, we have some legacy Postgres instances, but the bulk of our databases are either on top of MySQL, typically using our schema-less layer. That's another point. You have now schema-less. You have schema-less and using MySQL. Maybe there is something I'm missing here, but it does not seem natural to me. A lot of people use Postgres as a schema-less, like where they put a hunk of JSON in a single field as JSON-B, and they work with that. But maybe that's just the way for Uber, because they have a lot of fields and they have a lot of indexes on those fields. Maybe that's the way to go. Who knows, right? Again, guys, what do you think? What do you think about all that stuff? Let me know in the comment section below. I'm gonna see you in the next one. Hope you enjoyed this video. Give it a like if you do, and share it with your friends. I'm gonna see you in the next one. Thank you, Ivan Kiltizicki, a staff engineer in Uber Engineering. This is a great article again. Yeah, and things have been changing a lot in the Uber world. Well, this is a historical article that goes in the years and years.
Okay, what does that mean? Do I end the stream now? I feel like continuing. I guess I'll end the stream and maybe start another one again. We'll see. So that's it for now.